So, last page. This is part 3 of your Unit 1 review for your test. Okay. So let me just talk briefly about this. Accuracy versus precision. Whenever I'm figuring out accuracy, hopefully I spelled that right, you're going to take the average. Average of all measurements. Average. And compare. What do I mean by that? You'll see in a second. Okay? Whenever you look at precise, whenever I actually find precise, what you do is you take your largest minus the smallest, and that tells you your difference. The difference tells you difference. Okay, I can't spell that well. Alright. Basically, if we look at Ringo's right here, are they all the same? Yeah. So was he the most precise? Yes, absolutely. Okay, he was most precise because his measurements were exactly the same. We look at Paul over here, so that's question 2. Let's look at that right quick. We take his highest measurement, which is what? 0.4. And what was his smallest measurement? 34.3. Okay, so what this is called is standard difference or standard deviation. How far off were his measurements? So that ends up being 1.2 milliliters. So is that precise? No, not at all. So was Paul precise? No. So let's go back and look at number 1. What was John's average? So you're going to put it in there, 65.1 plus 65.3 plus 65.0 divided by 3. Anybody want to do that for me? Okay, so John's average was 65.13 repeating, etc. Okay, not going to worry about it. Alright, so what was John's average? There was that. If the correct value was 65.2, which was the most accurate? Okay, now without even looking at any of these guys, okay, who got closest to 65.2? John. Okay, so who had the most accurate? John. Now let's look at Ringo. Was his measurements accurate? No. Was it precise?
Yes.
Was it both? No. What was John's percent error? Okay, so here comes the percent error question. Remember the formula, percent error equals actual or accepted minus experimental divided by actual times 100%. What the heck did I just say? This right here is your actual. This right here is your experimental. So 65.2 minus 65.13 divided by 65.2 times 100%. Now, as my class is dutifully working on it, I want to remind you, you need to put parentheses around this part right here, because the way the order of operations is PEMDAS. Power, multiply, divide, addition, subtraction. So what it's going to do is if you don't put that in, it'll say 65.2 divided by 65.2, and then it'll say minus 65.13 times 100%. So you'll get the wrong answer. Instead, what I want you to do is this part first, then divide it by that part, then times it by that part. Anybody got a percent error for me?
0.1225.
0.1225?
Yep. No.
Okay, we're having conflicting results. Just a second. Alright, so what we ended up getting was 0.592%, yeah? No? Y'all didn't get that? Okay. So, it turns out I can screw up too, believe it or not. The actual answer was 0.107% because I rounded that many sig figs in there because that's how many I had in my original problem, which was 3. Okay? So, 0.107%. Alright, so let's look at some ugly looking rocks apparently. Alright, so I recently found 3 rocks. Woohoo. I have recorded their masses and volumes of each of them below. Now I'm not going to do this because it's pretty basic. Alright? But here we go. This is what I want you to look at. What is the formula for density? D equals what? Mass divided by volume. Okay? So for all of these, I'm going to find the density. Now, I'm not going to tell you how to do it because I want you to figure it out yourself. I'm not going to give you the answers right here. But for right here down at the bottom, which rocks would float and which would sink in water? So if density is less than 1, what are they going to do? Float or sink? Float. It floats. Alright, greater than 1. Greater than 1. It does what? Sinks. Okay? Now, down here for number 2, density problem 2, same deal. What's the density of it? Now, as a reminder, does the density of an object change? No. Even if I have a lot or a little, the density does not change. So remember that whenever you're going through these problems. Now, I want to do a couple more problems that aren't on review, so I want you to flip over to the back side for me right quick. Alright, I want to do a couple of dimensional analysis problems. First one, if I have 135 inches, that equals how many centimeters? Okay? So, since you don't have it in front of you, 1 inch equals 2.54 centimeters. So, the first thing you always do, draw a line down the middle. Whatever number is given to you in the problem, so in this case it's 135 inches, you put right there. Then over here, down here at the bottom, you need to put your inches, and at the top you need to put centimeters. Why? Because you need to cancel out inches. If I have inches on top, inches on bottom, inches cancel out. The only thing I need left to do is put my number. 1 goes on bottom, 2.54 goes on top. I multiply through, and I get my answer. Round to the right number of sig figs, which in this case would be 3. It's not 3 because of this guy right here. It's 3 because that's what my original measurement was. Okay? Unpause. Anytime. Okay. So, that right there, really easy one to do. Let's look at something a little bit harder. Let's look at the metric system. Okay? Remember that with the metric system, if I have anything, milliliters, milligrams, millimeters, okay, that is 1/1000th of a meter, or a gram, or a liter, okay? So if I have a milliliter, that's 1,000 milliliters equals 1 liter. That works the same for grams or meters. Grams or meters. Now, if I have a kilogram, so 1 kilogram equals 1,000 grams, or liters, or meters. Okay? The only thing you're really going to see is centimeters, so 100 centimeters equals 1 meter. Alright? Whenever you do these problems, make sure you do a reality check. Make sure you aren't being wrong with your measurements. So if I have, let's say, 36.8 milligrams, I want to know how many kilograms I have. I don't know an exact measurement jump from milligrams to kilograms, but what I do know is milligrams to grams and grams to kilograms. So what I do is I draw my line, 36.8 milligrams, draw a line. Class, what unit goes on bottom right here? mg. What unit goes on top? It's just G, because I don't know a conversion from the mg to kg. So look at this, and I go 1 on top and 1,000 on bottom, because that's what my measurement is right here. And then I do 1,000 grams on bottom and 1 kilogram on top. Now, whenever you're doing dimensional analysis problems that are 2 steps, whenever you put it into your calculator, it should be 36.8 divided by, open parentheses, 1,000 times 1,000, close your parentheses. Okay? Anybody have an answer for me on that one? What'd you say? Okay. Okay, and then what are my units? Kilograms. So that's it. Now, if you only have numbers on top, you don't need to worry, because it all works itself out. You guys got any more questions on that one? All right, so test is on Friday, 9/9, and good luck.